These may look like relics of the past, but they are actually the stepping stones to a modern-day marvel. The longest bridge of its kind on Earth, and the team has just 5.5 years to build it. They'll have to battle dangerous currents, winds in excess of 170 kilometers an hour, and take on the Silver Dragon. To make the construction even more difficult, this bridge isn't spanning a river, it's spanning an ocean. China's Hangchau Bay Bridge is the ultimate design and engineering challenge. A monster project with monster machines, and a construction zone like no other. If they succeed, it will be a man-made marvel. The dream, to bring two of China's busiest cities closer together. The two cities sit on either side of the Hangzhou Bay, a giant gulf in the East China Sea. On the south side of the bay lies Ningbo Port, the second busiest in China, with a handling capacity of more than 100 million tons. 350 kilometers away is Shanghai, the economic and financial hub of China, growing faster than any other city on the planet. Ningbo's future as an international shipping center will be fast-tracked if it can be linked to this dynamic and thriving metropolis. To make the dream a reality, engineers are designing the world's longest transoceanic bridge across Hangzhou Bay. The 6-lane bridge will cut the distance between Ningbo and Shanghai by more than 120 kilometers. But between these two mighty urban centers lies a vast stretch of ocean that until now has been beyond the reach of bridge builders. From the onset, chief designer Wang Ringgui knew he would have to work magic.
When I was first put in charge of the design and planning of the bridge, I was very excited. However, when I got here, the natural environment proved to be much worse than I imagined.
Dr. Robin Shan and Naeem Hussain are world leaders in bridge construction. With 60 years' experience between them, they know all too well the natural obstacles facing the bridge builders.
This area is one of the most hostile environmental area in terms of bridge building.
The decision to build sea crossing of this nature demonstrates man's desire to harness the forces of nature for the benefit of mankind.
Salt water, swift currents, and strong winds don't mix well with concrete and steel. And this is just the tip of the environmental iceberg threatening the engineers.
The more we got to know about the natural environment, the more difficult we realized building the bridge would be.
But the designers and engineers must overcome these challenges and more. At a total cost of nearly 12 billion yuan, the bridge represents the future of the region's economy. But a freak force of nature could see the dream over before it's even begun. Hangzhou Bay is home to the Dung River tidal bore, a giant wall of water that forms when extreme high tides, carried on the strong currents from the bay, force their way into the narrow river mouth. The power of this water is so great, it causes the river to flow backwards and produce the giant wave. The Hangzhou Bay tidal bore is known as Silver Dragon, and every year, in the middle of the 8th lunar month, it wakes up. Reaching speeds of 40 kilometers an hour and heights of up to 9 meters, it's the largest and most spectacular bore in the world. And every year, hundreds of thousands of tourists come for a front row seat. But this natural wonder is unpredictable and dangerous. To date, the mighty dragon has claimed the lives of at least 100 people. And this remarkable phenomenon could claim the bridge before it's even started. In a bizarre twist, it's not a case of if the bridge can survive the dragon, but can the dragon survive the bridge? Before the designers can begin, hydrologists need to know what they are dealing with. The bridge could alter the flow of water through the bay, destroying the silver dragon and a multi-million-dollar tourist attraction. They undertake extensive studies of the Qiantang River's flow, as well as the tides and currents in the bay. Then replicate these findings with a scale model of the bay, complete with a prototype of the bridge.
The current for the model and the actual current are very similar. The experiments give us results on the effect of the tide and direction of water flow.
From these experiments, Dung works out exactly where the foundations must go to minimize the bridge's effect on the currents. The result is a bridge in...
And then the red tips. So then what we do is unmask all the latex, peel